In this video, we're going to solve the following problem. The following problem is actually pretty easy. It's just basic exercise in your calculus skills, right? Suppose the position particle is given by x of t is equal to 6t squared minus 10t plus 5 meters. What is the, so that should be the entire thing enclosed. What is the instantaneous velocity? What is acceleration? Okay, so let's basically do it. So the instantaneous velocity, if you recall, is going to be basically the derivative of x with respect to t, right? So this is going to be the derivative d by dt of basically what? What's x? 6t squared minus 10t plus 5. Or basically taking derivative of stuff raised to a power is basically d by dt of t to the n, okay, of, well, ct to the n, where c and n are constants. This is equal to basically c times n times t to the n minus 1. Okay, so n, c are constants. Okay, so when you apply this to this particular rule, it's basically d by dt of 6t squared plus d by dt of 10t. In this case, it will be a minus sign there, and then plus d by dt of 5. All right. This is derivative of a constant, so it's just going to be basically equal. So let's do one by one. 6t squared, so it's going to be basically 6 is going to be c times n. N is going to be 2, so 6 times 2 is going to be 12. Okay, then it's t to the n minus 1, which is 2 minus 1, which is 1. So that's 6t, 12t. And then for this one, basically it's going to be minus 10, right? And then n is 1, so that's 1, 10 times 1 is 10, times t to the n minus 1 is t to the 0, which is 0, so that's just basically minus 10. And then for the last one, this is t to the 0, so c, which is 5, times 0 is 0, so this last term actually goes away, right? So there it is. That's the acceleration. That's the velocity right here. This thing, meters per second, keeping in line with all the units here. Right, let's get the acceleration now. So the acceleration is equal to the total derivative of v with respect to time. Right, so it's going to be d by dt of what we just computed out, 12t minus 10. Right, and if you just do it, okay, you can just basically see this is just only one term comes into play because this term right here was a constant, and d by dt of a constant is always 0. So that's 12, and let's put the unit right in, meters per second squared.